In this video lesson, we will learn about similar triangles. So, there's actually several video lessons about similar triangles, and this one will be about recognizing them and about the rules of recognizing them. So first, what is a similar triangle? Well, it's actually one triangle similar to another triangle. There's congruency of triangles, which means the same thing, and similar means that you have a scaled version. So like here I have drawn two triangles, and they're the same shape, just one of them has been scaled down. Kind of like when you print something on paper, you can rescale it to make it larger or make it smaller. In this case, the triangle is the thing that has been rescaled. So these scaled triangles are called similar. Similar to congruency, there's a certain set of rules in determining if triangles are or are not similar. There's AAA standing for angle, angle, angle. So if you know that two triangles, a pair of triangles, shares the same set of angle measures, then they must be similar. Another option is SSS. Now, in the case of congruency, all sides have to be equal. But in the case of similar triangles, all the corresponding pairs of sides have to be in the same ratio. Meaning, if you have one triangle, and then you have another triangle, here I've labeled A, B, C, and X, Y, Z. The same ratio means that if you take the corresponding sides, like A corresponds to X, you take the ratio A over X, that equals to the ratio of B to the corresponding Y, or to C corresponding to Z. So this is all of the sides in the same ratio. That's what is meant. Now SAS, side-angle-side. So that is when you know for two triangles that first of all there's an angle which is equal, and second of all the two sides around that angle are in the same ratio. Now this is similar to the SSS ratio thing, but instead of three sides you only know about two of them, and also the angle between them for it to work. So these are rules, and here I'm just circling. The A over X equals B over Y is what applies in SAS. So now let's do a few examples. Are the triangles similar? You'll notice that in the congruency video, there's actually the same example. But here we're going to solve a slightly different question. Are they similar? Well, let's calculate the third angle of the triangle, because we can't know for sure until we know all three. We have 58 degrees plus 58 degrees plus X equals 180 degrees. And X is, I've labeled the missing angle. So we solve as usual, and we get 65 degrees. So some of you might see where this is going already, because the other triangle has an angle of 65 degrees, but we should solve for this missing angle first to be sure ourselves of what's going on. So I labeled it Y, and we have Y plus 58 degrees plus 65 degrees equals 180 degrees. And we keep solving. Y plus, and 58 plus 65 is 133. And this is equal to 180 degrees. And I solve for Y, and I get 57 degrees. And hey, look, we have 58 and 58, 65 and 65, and 57 and 57. So all the angles do match up. Yes, the triangles are similar by AAA, or angle, angle, angle. All right, let's move on to another example. Are the triangles similar? So we have an angle measure, and both the angles match up, which is good. Then we have 12 corresponding to 6, so 12 over 6 is 2. That's the ratio the larger one to the smaller one. And then we have 20 and 10 are the corresponding other sides, and 20 over 10 is equal to 2. So yes, since both ratios are equal to 2, we have equal ratio and equal angle in between the two sides with equal ratio. So yes, the triangles are similar by SAS. Great. So now a final example. So in this case, all we know is the 3 side lengths of both triangles. So if it is similar only if SSS works. So we calculate the corresponding sides. We have 8 over 4 is equal to 2. 6 corresponds to 3. We divide by 3 to get 2. 7 corresponds to 3. But 7 over 3 is not equal to 2. It's actually equal to 2 and 1/3. So as you can see, the ratios are not all equal. 2 of them are, but the third one is wrong. So by SSS, the triangles are not similar. Alright, well I hope this helped, and thank you for watching.